Welcome to the DSA series. In case you're wondering what you're doing here, I'm sure you're interested in DSA, data structure and algorithms, which is why I've stumbled upon this video. In case you're wondering who I am, my name is Kallol Bhattacharya, and I have been in the IT industry for the past 24 years, recently retired. And I thought that my knowledge in the IT industry is best put to use if I am with you and I'm trying to impart whatever I have learned in terms of these lecture series. DSA, Data Structure and Algorithm, is going to be an exciting series, and we will cover everything from the basics of DSA to the advanced concepts of DSA. We will cover a plethora of questions that are typically asked in the university curriculum. So anybody who is interested in DSA as a topic, as a subject, anybody who has DSA in their university curriculums, they can definitely benefit out of this. Be with me. I'm sure this is going to be an exciting journey in order to prove how and what modern algorithms can do. Thank you so much. Hello. Welcome to the DSA series, and today we talk about Infix and to some extent what are they, how does stack help in evaluating functions. That's the topic of today's discussion. Good afternoon wherever you are. We have started and we had completed stacks in one of our previous lectures. Please feel free to browse through that of stacks, which is around the infix, postfix, and prefix expression evaluation perspective. So what is infix, what is postfix? Don't worry about that. We will get to that in a short while. We are trying to upload module 2, and these modules will be different modules in different university curriculums, but stacks will definitely be there under any of the curriculum modules, and we are trying to attack that module. Infix, postfix will be there in any kind of a university curriculum module on DSA. We are trying to attack that module. So that's what we are trying to do. We are doing this particular topic, which is around the expression conversion and evaluation corresponding algorithms and complexity analysis. So that's what we are trying to do today, which typically spans across the infix and postfix notations. And post this, we will start queues, which will be part of our module 2, and that would be the last part of module 2. Now, today's agenda is on the infix side. We will be doing the demerits of infix. We will talk about how to resolve an infix expression. We will talk about how to convert an infix expression to a postfix expression. And then we will also see how to evaluate a postfix expression. And all of this we will repeat both algebraically as well as using stacks, because we are talking about stacks in the last couple of lectures. We will stick to that. We are actually right now talking about the application of stacks, and infix and postfix resolution is one of the applications of that. Needless to say, we will end it up with the solution to common problems, and that's where we will be talking about various problems. You will see there is a plethora of questions that comes from this particular topic. Now, that being said, if we start off, we are basically trying to say what is an infix and what is a postfix expression. Now, nothing to worry about. Infix is very easy to understand. You have been doing it for time eternity now. If this is an expression, right, all of you can understand this is an expression. Here is what we call as an operator, and these are my operands. And this operator here is actually nothing but your binary operator. And the reason why it is a binary operator is because it is basically having a operator. The operator is actually having an operand on the left and the right side of the operator. So that is the reason why we are saying that 4 and 2 are actually nothing but your operands. So how many operands are there? There are 2 operands, right? If there are 2 operands on this operator, then basically we will typically call it as a binary operator. So plus is a binary operator. This what we call as the exponent is also a binary operator. This is also a binary operator. This is also a binary operator. Now, where we are trying to get at is that all of these operators are actually residing all of these operators are actually residing in a section where we are trying to see that this operator is actually residing in a section which is in between these 2 operands, right? So we can say that the operator is in between these 2 operands, right? Or we can say that it is infix. Infix would mean that in a place which is fixed in between these 2 operands, right? And that's where we will therefore term it, or we will therefore understand it as an in-between kind of a model, where the the binary operator that we standard know as, right, whatever the binary operator is meant to do, sit in between two operands, and that is what is an infix expression. That is what is an infix expression, which we have been solving for time eternity now, right? So how do we solve this? Let us see how do we solve this. So we can say that we have to definitely remember this precedence table, which all of you know about, because when you are doing this, you'll have to understand that exponent will actually happen first, right? Because my exponent is here. Sometimes the exponent is also called as dollar, so be aware of that. In your university papers, dollars may also come in lieu of exponent, but both have the same meaning, right? It is an exponent at the end of the day. Now, these exponents or dollar, whatever it is, will come after the brackets. So if there is a bracket, it will be always evaluated first, then comes your exponent, then comes your addition, subtraction, and modulo operators, and then comes your plus and minus, right? So that's the order of precedence, and I'm sure all of you know about it from your C days. We are just trying to apply that. Now what we have here is 4 plus 2 star 3. We see that there is a 2 star 3, so we will say 4 plus, we will evaluate 2 star 3, because this is something that needs to be evaluated first, right, as far as the precedence is concerned. So 2 to the power 3 is actually 8, and then we will write the expression as it is. Next, we will say that 3 star 5 is higher precedence than 4 plus 8 or 8 minus 3, right? So that's where we will say that 3 star 5 has to be done first, and we will do this. Then we will say that plus and minus have the same precedence. If it has the same precedence, then the associativity comes to our rescue and says that left to right, whichever comes first, we will do in that order. So associativity says do plus first. So 12 minus 15, we get 3, negative 3. So that's the output of this particular expression. If you see this particular expression, you have seen that we have taken actually 4 passes to actually solve it, right? So we could not solve it in one shot. We could not say that we will go from here and then every element we will keep on solving as we go forward. We could not do it. We have solved it one at a time. So we have solved the first precedence, or we have solved the first precedence. Then we have solved the second precedence. So we are going back and scanning the expression again. So we scanned this expression, we created this expression. Then we scanned this expression, right? So then we scanned this expression and we created this expression. Then we scanned this expression and created this expression. So all the while we are keeping on scanning the previous expression to actually get to the next expression. So remember this point, because this point is actually one of the disadvantages of infix operation, which is basically pointing out the fact that it does multiple scans, right? So with that, if we actually do one more example, let us see here. This example has brackets. So of course brackets have to be done first. So the first pass will do this in terms of solving the brackets, which is 20 star 5, right? Now then if you see, the stars are appearing in this, and these stars will have to be done in before the plus and minus, and the first star will be done first. So this will be 100, and then we will have minus 20 into 5, and I'm sorry, this will be 1000, and then we will have minus 20 into 5, and then this will be evaluating the star here. So 9 plus 1000 minus 100, and then we will have plus and minus have the same precedence. So we will say 1009 minus 100. We did a left to right associativity, and then we have 909 as our answer for this, right? So I hope you can understand that this multiple scans is kind of something that is a disadvantage for solving infix expressions. And you can also understand that you need to know the precedence and associativity table in order to solve this particular expression when given to you in an infix notation, right? And so that means that whoever you are giving it to, whether you are giving it to a human being or whether you are giving it to a computer, these two will be hindrances. These 2 points will always be hindrances. A computer will take more amount of time because it will have to do multiple passes. So it will have to do a pass here, 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 and if the expression is big, it has to do so many passes. And at the same time, it is also supposed to remember this associativity and precedence table and apply it while doing the passes. Right? So that's the disadvantage of an infix operation. So what do? We will therefore try to convert it into something that the computer understands and computer loves, in the sense that a data structure where we can say that the computer is happy to have this data structure, and the computer is happy to know this data structure because it can solve this data structure without these two problems. That is, it doesn't need to know precedence associativity, and it will be done in one pass, right? So if that can be done, then the computer will be happy, everybody will be happy. Even human beings can apply that. Not that they do it conventionally because they are brought up to actually do it in an infix notation, but if they can do it in a postfix notation, it would have saved a lot of time in terms of multiple passes and also remembering about the precedence table. You don't need to remember about that. So if I go ahead and see this this particular expression, how to convert it into a postfix expression, right? Again, to convert it, anyways, I will need to remember the inherent problems of infix will still be there on the conversion side, right? Once we convert, then the problems will go away. But during conversion, the problems are still there, right? So we still have to understand that there is an associativity and precedence for this, which will be first in the queue. So we will say that we will write 4 plus this expression has to be evaluated first, right? So we will say that we will move the operator, which is the exponent sign, after writing the 2 symbols or the operands, and push the operator to the right of the operands. I gave a small dot here just to distinguish that this is not 23. I could have just written 2 and 3, but I gave a small dot here that signifies that these 2 are different numbers. I hope that is understandable. And then I will write the rest of the expression. So this is my first pass. The second pass, what it will do is, now remember, you will have to treat this as one operand, right? So you'll have to treat this as one operand. It is you have to treat this that if somebody would have evaluated this would have been 8, right? So 8 is represented like that. So this entire blue circle is one number. Do not treat any of the individual elements inside that blue circle as anything else. Everything inside the blue circle is one number, right? So this is one number and this is -3, right? That is how you should evaluate. One number here and then -3. Which one do we do? We do 3 star 5, right? We don't do this number -3. Minus is lesser precedence than star. So what we will do is we will say 4 plus 2.3 exponent minus of 3 star 5. 3 star 5 is, we will write 3, we will write 5, and then we will move the star to the right of it. And therefore, now we have this as one number and this as one more number, right? So these two are separate numbers. Now if you see, and this of course is one more number for us, right? So if you see now it becomes clearer that plus and minus are pending. So plus has to be done first because plus comes to the left. Precedence is now coming here, rather associativity is coming here because plus and minus have the same precedence, right? So we will do plus first. So this blue and blue have to be written back to back. They are 2 numbers, as I said, right? So blue is what? 4. Next blue is what? 2.3. Next is this. So these are the 2 numbers which are in these blue boxes, right? And then we have to put this plus, which will go to the right of the 2 numbers, right? So these were my 2 numbers, originals, and position these 2 numbers and plus sign after those 2 numbers, right? So I hope you can understand this part of problem. Come back to where it was. Then I still have a minus here with 3.5, right? So that's the thing that I have. Now this particular problem that we have right now has become. So this, we applied the plus, right? So this became a composite number. So this is one big number now. And this was already one number, right, from our previous step. So all we need to do is do a subtraction now, right? So that's all that is left. So we will bring this down, then we will bring this down, and then we will put a subtraction sign at the end of it. So we will write 4.2.3, then we'll put the exponent sign, then we'll put the plus sign, and then we will write 3.5 star, and then we will put the minus sign that needs to go to the rightmost portion of it. So now this particular thing becomes one big number, right? So this is the solution of the postfix conversion of the original number that we started with. So the infix has now been converted to the postfix notation. Now, if you see this postfix notation, and when we go to the postfix solution, you will understand that if somebody has this postfix, there is only one pass with which he can solve it. There will be only one pass. We don't need so many passes to solve it. And if somebody has this postfix, then the precedence, the associativity is all built into this expression. There is nothing to remember about precedence and associativity. It will be very mechanical for you to solve it. And we will go to that. And that's why the computer loves it, right? And that's why all computer algorithms that evaluates expressions typically rely on postfix. Postfix is also, by the way, called as a reverse Polish notation. So reverse Polish notation says that if there is an expression like a and a plus b, then it can be written as a b plus. So that is reverse Polish. The forward Polish notation, that is basically called as prefix. The prefix notation says that if there is something as a plus b, then it can be written as plus a dot b, right? So that is something that you should be remembering, that postfix and prefix are actually coming from the Polish notations. So normal Polish notation is prefix, which is a plus b is equal to plus a dot b, and reverse Polish notation is where the operator goes to the right of the operands, which is a dot b plus, right? And infix, as you know, is in between. The operator is in between. So that's basically your infix, postfix and prefix. Now, with that in mind, if you understand this concept, let us try to solve this also, right? Let us try to see what this comes to, right? Now, what we will do here is, again, we will move with what the infix associativity, infix notations are trying to tell us, and we will first be solving the bracket part of it, right? So if we go to the bracket part of it, we see 3 plus 17 has to be solved. So we will write 3, we will write 17, and we will put plus at the end of it. We will remove the brackets. There is no concept of brackets in postfix. And we will also have star 5 here, right? Now, if I see this expression, scan this expression, I will see that there is a star here, there is a star here. Do not forget, what you have got is a number here, right? This entire thing is a number, which you would anyways be evaluating, which is 3 plus 17, right? You would have evaluated that as 20. So 20 resides inside this blue box. It is just represented as 3.17 plus from a RPN standpoint, that is reverse Polish notation standpoint, or a postfix standpoint, right? So we will treat this as a full number going forward, right? Next, we are going to evaluate 200 star 5. So 200 star 5 is going to become looking like this, 200.5, and then we will put a star. And then we will say that negative of this particular number, I'm sorry for this bracket, let me rewrite this. There should not be any brackets in RPN. So we are going to say 9 plus 200.5 star, and then we will say minus 3.17 plus star of 5. So that's what we will say. Do not forget that this was one number for you, and we just now did this number, right? So this is one more number. So what do you see? You see as this as one number, and this as one number also. So you see 4 numbers, and you see 3 operands, right? So that justifies what is left of this expression. I hope you are understanding. Now here, what do you see? You see there is a star here, right? So this star has to be tackled. So if this star has to be tackled, then what we have to do is we will keep the rest of the expression the same, 200.5 star minus 3.17 plus, and then we have a star which needs to be applied, right? So we have this as a number. So the next number is 5. So we will bring the next number and we will put the operator on the right of that. So what we just now did is we had originally this number at the top and we had this one more number on the right. We anyways had this as a number which we did not evaluate because it had a plus here, and we also had this number. So these two numbers from the top, we have merged it together and moved the operator to the right of it. So that's all we have done. So net what we have achieved is that we have and now we can, therefore, because we have merged it to the right, we can therefore say this entire thing is a number, right? I hope you can understand now. Because we have merged it, we have evaluated it, we have done the postfix operator, then we can say that this is right now a number, right? Now if I go to the next step, we have this plus is pending, this minus is pending, right? And these are the three numbers, right? The three circles that you can see. Now these three numbers plus will obviously come first in terms of associativity, because plus and minus have the same precedence, needless to say. So we will have 9 as one number, we will have 200.5 star as one more number, and this plus will go beside it, right? So I hope you can understand. So what we did is, this was our smaller set, this was one more smaller number, and we combined this with the plus sign. So now we have this as my larger number, right? And then we also have a minus sign here, and we also have a 3.17 plus 5 star, and this anyways was a larger number from the previous step. So now we have to apply this minus, and the final step of applying this minus we are trying to do now. So what we will do is, we'll take all the numbers as is in between the boxes, 205 star plus this minus we will apply to the end of the numbers. So we will bring 3.17 plus 5 star, and then we'll put a minus, right? So this minus comes here, and this is our final expression. This is the final expression which is in the postfix notation, which we have solved just now, right? Again, as I said, this removes the concept of multiple passes. When we will try to solve it, the next step we will try to solve it, it will remove the concept of multiple passes. It will remove the concept of knowing the precedence and associativity of the operators. So let us see that when we try to solve this expression. I hope you are understanding how infix is converted to a postfix, right? Now next, if we actually get into the postfix evaluation, right? All we did was we did all of this, right? So if you see, we had got this expression. Yeah, so just see this, what we achieved versus what I have written down here, right? So 4.2.3. So we have 4.2.3, then we have the exponent sign, then we have a plus, then we have a 3.5, and then we have a star, and then we have a minus. So this expression is correctly written here, and we are now checking this expression, which is 9.200 into 5 or dot 5 star plus 3.17 plus 5 star minus. So what we have achieved out here is the correct postfix expression of that infix expression. And now what we are trying to do is, we are trying to solve this postfix expression to see what value comes out of it. Do not forget that when we solved it in the infix mode, we had got these values, right? Do not forget that we had got -3 this side and 909 this side. This is the same expression, right, which we are taking forward. So we should solve this to get that -3 and 909 on this side and that side, right? So that's what we will try to do now, and we'll show you that we'll show that how easy it is now to work on the postfix side of things, right? So what we will do is, this works on the concept that it goes on from left to right, and until it finds an operator, right, it doesn't start working. So what it does is, so it goes from 4, it goes to 2, then it goes to 3, then it finds an operator. When it finds an operator, the last two operands, right, the last two numbers, now they are no more, they are operands at the end of the day, but they are not in between, right? So of course you can treat them as the last two operands. And these last two operands, we are going to apply the operator on that last two operands. So what will happen is this will become 8, right? So we are done with this, we are done with this, we are done with this, right? So now we will write the rest of the expression as is. Once this is done, we are now again, while the pass is not going to happen again, but I'm writing it in multiple steps for your easier convenience. Remember that we had evaluated till this point, 4 was there, 8 we evaluated. Now we are in a position to evaluate on plus. We are not going back and checking which is plus, which is star, which is plus. We are going forward from the point where we stopped, right? So that means that it is only one pass. We are not going back and forth and understanding precedence and all of that. We were here, we calculated our 8, and now we are moving from here to the rest of the stuffs, right? So from this point only we are moving. Hence, I am just showing it in different steps. It could have been done in one single step. And it is done in one single step as far as the computer is concerned, right? So what we are right now here, right? So what do we see? We move to the next step. We see a plus. Right? If we see a plus, I told you, right? If you see an operator, you will apply that operator to the previous two operands, right? So apply this to the previous two operands. So what happens? 8 plus 4 is 12, right? Write 12 and then write 3 because plus is already taken care of. So write 3.5 star minus, right? So now you were here, right? You had applied 12. Now your job is to move to 3. So move to 3, that is fine. Move to 5, that is fine. You are not getting an operator. That's why you are waiting. Now you have got an operator, right? Apply that. So what do you get? 12 dot, and you have to apply star to the last two numbers, last two operands. So you get 15. So you are done with this, you are done with this, you are done with this, right? So all you are left with minus. So now you have got minus. So you are here, right? And now you move to this. So this actually gives you as a minus. And you have what? You have got an operator. So take the last two operands and apply that operator to that last two operands. What do you get? You get minus 3. This was the answer which we got in the first step also, right? So this is how, without knowing anything of precedence or associativity, you have achieved what your infix expression was achieving just in one pass. And I hope you can understand that this is just one pass and not multiple passes. The way I wrote it, this is for your own convenience that I've written it, but I've always started from where I left off in each of the steps. Let us see how this can be solved, right? Again, we will go and take this number, and then I reach an operator. If I reach an operator, I will apply the operators on the last two operands. So what will happen? 9 dot 200 star 5 will be 1000, right? And then I will put whatever is there. And then my pointer was here. I applied till 1000. I get one more operator. As soon as I get it, I will apply it. So it will become 1009. Then I will keep whatever is left, 317 plus 5 star minus. Then I will go, now I am where I have applied plus, so I am at 3, right? So my pointer is at 3. I will go to 17, I will go to plus. As soon as I reach plus, what will I see? I will see that 17 and 3 are supposed to be added, right? So I will say 1009 dot 20. I have applied till plus, so I will say 5 star minus. So my pointer is right here. I get 5. I go to star. I get an operator. If I get an operator, I'm going to apply that operator to the last two operands. So 1009 dot apply the operator to the last two operands means that 220.5, right? 20.5 will become 100. That is 20 star 5 will become 100, and the minus sign will be there. So I applied till 100. So my next step is to go to minus. Minus is an operator. Apply the minus on 1009 and 100, right? So what we get is 909, which matches with what we had got earlier also, right? So this is how we are trying to say that our infix has or our postfix has solved the problems by not needing to know the precedence or associativity, and there is a single scan of evaluation. And this is what is so unique for Postfix or RPN, which is where it tries to give you the solution for computer systems to actually evaluate expressions. Now this, I hope you understand that this is so easy for a computer to probably do, because it is so mechanical. It just goes from left to right, applies the operator to the previous two operands, and hence gets the output. Now, is there a way by which we can use stack to help the computer, right, to do this? That is what we will try to see now. So let us do first the conversion of the infix to postfix using stacks, right? So if we do the conversion of infix to postfix using stacks, then we will have to remember certain rules, and these are the rules that I will try to write down, and these will be the rules that will be applied to you when you are actually seeing the algorithm of postfix. Sometimes you may be asked to write the algorithm of infix to postfix conversion, and that's what I'm trying to write down in terms of the rules that I will just now write. So let's take a stack like this, and if you have seen the stack lecture, if not, just go back to the previous lecture and you can see in the playlist. In the stack, what we have is we will keep this stack like this, and the rules are that if there is an operand, then let's say case 1, if there is an operand, then write it or print it, right? So that's the first rule. So I will print the operand, which is 9, right? So I know you might be confused as to where we are going, but then it's a simple black and white rule. You have received, you are going from left to right of this expression. You are trying to convert this expression into postfix. You know what the postfix will be. I'm sure you know what the postfix will be. The postfix will be this only, right? So this is the postfix. We arrived at the postfix here. If you see, the same way we arrived here. Can we do this postfix expression using stack is what we are trying to say. Instead of algebraically doing it, can we do it using stack? If we can do it using stack, then any compiler can actually be built, any code can be written to actually use the stack to solve this in a postfix manner. So first the infix will be converted to postfix, and then the postfix will be solved by the computer system using stacks, and that's a much easier problem to solve, right? So that's what we are trying to get at. So now I have written 9, so that's my rule. 9, I move my pointer to the next element that I see in this expression. It's a plus. As soon as you see an operator, right? So case 2, as soon as you see an operator, push it to the stack, right? So operator will be pushed to the stack, right? So we will push this operator to the stack, and we will say that I have plus now here. Next step, I get an operand. It follows this rule, right? It follows this rule. So I will put this operand here. I'll just put a dot here just to separate out the numbers. So 9.200 is what I have obtained in the final output, right? Now I see that I get a star. So if I see a star, right, I will try to push it at the top of this. Now, if I push the operator, right, the operator push will have some conditions. Now, if the operator is greater than in terms of precedence, if the operator is greater than in terms of precedence of the previous or of the top of the stack, whatever is the top of that, then the operator will be pushed. So what are we getting here? We are saying that star is supposed to be put. Is star, what is the top of the stack? Plus, right? The top of the stack is pointing here. Is star greater in precedence as compared to the star, is as compared to plus? If so, push it. If so, push it, right? So that's what we are saying. Say if the operator is greater in precedence to the previous operator, that is the top of the stack, then push the operator. So I will push the operator here, which is fine. Now I get 5, right? And if you see the expression we are trying to get at, see 9.200.5, we have already achieved 9.200.5, right, as we go forward, right? So 5 is also done. Now we get minus. So it follows this operator, right? Operator push, operator greater than precedence, is minus greater than the top of the stack operator? No. Minus is not greater than the top of the stack operator. Top of the stack operator is right now at star, right? So top of the stack operator is right now at star. So what we will do is, if the operator is not the same, if the operator is not higher precedence, so if the operator is less than equal to the precedence of the top of the stack, then pop the operator that is of the higher precedence. So the operator was lesser, right? Whatever the operator was coming to you, this minus was lesser, right? Because we had star at the top of the stack. So pop the star. That is what we are saying. So pop the star, right? So pop the star means star comes here, right? So we will pop the star from here. The star is no more there. Now, if the star is no more there, what is the top of the stack? Plus, right? Now we have plus at the top of the stack, right? So now, again, apply this rule, because you could see that there will be one more operator which might not allow you to get on top of it. Point number A says what? The operator can only go to the top of the stack if everybody below it is of lower precedence, right? Operator has to be higher precedence. So therefore I actually pushed this out or popped this out from the stack, right? So that I can get a lower precedence operator. But is plus a lower precedence operator as compared to minus? See, it is less than equal to. That means this operator has to be exclusively greater in order to go into the stack. So point A says greater, right? So minus has to be greater than anybody for minus to get into the stack. But minus is not greater than plus. So plus will also have to be popped out. So we will pop out plus also. And then if I apply point A, right, minus can actually get into the point A, which is that minus will say that now nobody is in the stack, no one is there who is actually higher than me or equal to me. Therefore, I will now push myself into the stack. So this rule therefore then triggers, right? So I hope you're getting where I'm moving towards, right? So now this minus goes there. I am done with this. Now we have 3. In fact, we have brackets which are coming in. So if there is a bracket, then the rule of the thumb is that blindly put the bracket on top, because a bracket has always a lower precedence, right? So if a bracket has lower precedence, then in fact I did some mistake here, because this is not the top of the stack. The top of the stack is this, right? So the blindly put the bracket there, and it has the lowest precedence. So we will put the bracket on top of the stack. When we push for the bracket, so that also has to be a case, right? So I cannot just write this like this. It has to be part of my algorithm. Opening bracket, push it without any consideration of precedence or hierarchy. Do not check whether this is greater than this or not. Greater than means this one. Do not check this, because this is not an operator. This is a bracket. So the rule says if there is an opening bracket, push it blindly. And always treat a bracket as the lowest precedence when you are comparing. For pushing, don't do any comparison. Just push it. When you are comparing with somebody else, right, later on you will see, you will have to treat bracket as the lowest precedence. We will see that, right? So this bracket is also done. Now we have 3. 3 is case 1. So it's an operand, right? So we write 3 here. Then we have plus. Plus is what? An operator, right? Operator is supposed to be pushed, but only if these 2 conditions are, any one of them is satisfying. What is the first condition? Is the plus greater than the precedence of the top of the stack? So is plus greater than the next one item? If I push plus here, will plus be greater than the bracket? Yes, because as I said, treat bracket as the lowest precedence. So plus can be here, right? And if this is okay, I don't need to go down. I don't need to go down at all, because anyways I'm addressing that as I move forward in the stack. So the immediate next, if I satisfy the condition, I don't need to check anybody else. right? So plus is, of course, okay to come here, right? So if plus is okay to come here, what is my next step? My next step is 17, right? So 17 will now be an operand, and hence it matches with case 1. So I write it here. Then I get an end bracket. A rule for end bracket I have not written, right? So we will write the rule for end bracket. End bracket. End bracket means pop everything till you reach the beginning bracket. That's what you will do. Pop everything till you reach the beginning bracket and discard all brackets. And discard all brackets. Right? So pop everything till you reach and beginning bracket. So you have bracket here. So bracket will come here. So pop this, because I have to reach till this bracket, right? Pop till I reach this bracket. So this plus will come here. This bracket will be popped, but I said discard the bracket, so I will not write the bracket here. And since I've reached this bracket, I will not discard anymore. I'll not pop anymore, right? So that's bracket's job is done. So this job is done. Then I have a star. My star will go here because this is my top of the stack, right? And can star go here? Just check. Yes, operator is greater than the precedence. Previous one is minus. Star has a greater than precedence, not even greater than equal to. It has a greater than precedence. So star will go here, right? Next, what do we have? Next, we have 5, right? So we have 5, and 5 will be an operand. So it will go here, and this 5 will therefore be staying here. And after this 5, there is nothing else. So if there is nothing else, case 5, no further expression would mean that pop all from stack, right? So that is what the algorithm, case 5 of the algorithm is trying to say. Pop everything from the stack and just write it here. So I pop this, and I wrote these here, right? And if you see, this should be our final expression, right? Let us check it, that whether we have achieved what we wanted to do. 9.200.5 star plus 3. I have a star plus 3, 3.17 plus 5 star minus, plus 5 star minus. So I achieved what I achieved here, and what I started with here, and what I achieved here. They are the same thing. So what we have achieved is, we have achieved a way by which we can use a stack to help the computer to convert an infix to a postfix, right? So that's the understanding from this particular topic. On the left, what you see, the cases, these are your, this is what the algorithm is. You can write it in a bit more English manner, and that should be enough for you to probably score marks if at all this infix to postfix algorithm is asked, right? So that's on the infix to postfix. Now that you have got this postfix, let's solve it also, right? We had solved this to this particular 909, right? We had solved it algebraically. Can we solve it using stacks, right? So because that's the whole intent of converting to an infix using stack. Computer is happy. We have converted it into an postfix expression. So computer says, if you give me postfix, I can solve it. So we give it a postfix using stack. Now, can it solve it using stack also? That's what we are trying to achieve, right? So what we will do is, in this case, it's actually the reverse, right? So what the algorithm says is that if you receive an operand, push it into the stack. If you receive an operand, push it to the stack. I have received this, I've pushed it to the stack. So if you have an operand, then push, right? 200, I will push. Then 5, I will push. Now, if you receive an operator, case 2, if you receive an operator, then do what? You will have to apply that operator to the last two, or rather, let me write it in this way. We will say that pop last, or pop 2 times. There is nothing called last. Pop will always be last, right? So pop 2 times. Pop 2 times. The first time you pop, you get A, let's say. The second time you pop, you get B, let's say. So apply that operator which was plus, or apply operator which was my star here, right, on the B as an A as like this. So apply the operator, whatever that operator is, right, with B and A like this. So you will pop first, you will get A, you will pop next, you will get B, right? And then operator has to be here. Please don't forget this sequence. This sequence is so important. For division, for subtraction, if you don't follow this sequence, you will be in a big mess. So remember that the second one popped will be the first item to apply in the expression of B operator A, right? So now what will be the output? So we will pop 5. 5 has become my A. We will pop 200. 200 has become my B. And we will apply this star on this 205 as this. What do we get? We get 1000. Push 1000 back into the stack. So this will be push result into stack, right? So that is how the algorithm should go, right? So now we have 1000 here into the stack, right? Now what do we have? We get plus. You know what? You have to go to case 2. You have an operator, pop 2 times, pop 2 times. So 1000 is popped, 9 is popped. Apply the operator plus, you get 1009, right? Push that 1009, because they are popped, I have discarded them. Push the 1009 into the stack, and that completes your case 2, right? So case 2 algorithm is done. So 1009 is gone into the stack now. What do you get next? You get 3. Put 3 here, because that applies to case 1. What do you get next? You get 17. Put 17 here, because that applies to case 1. Then you get a plus. So what do? You will pop 17, you will pop 3, and you will apply plus to that. So you get 20. This 20 you will move where? You will move to the top of the stack again, right? So this is the 20, you will move to the top of the stack, right? Now you have 1009 and 20 on the stack. So now you have got 5. So 5, move it here because it matches with case 1. Then you get a star. Star means you'll have to pop 5, you will have to pop 20, and what you get is star of this, which is 100, right? So now what you do, take this 100 and push it into the stack. So you are here, so this is your top of the stack, so push 100 here. Next, what do you get? You get, we have done with star, right? So we are now left with a minus, right? So if I apply minus, that means I have to pop 100, I have to pop 1009, right? And I will have to apply minus here. And that's why I was saying be careful. So now what you get is 909. And this 909 exactly matches with what you had found out from this particular expression, right? In the algebraic mode, you found out 909. Through stacks also, we calculated 909. So this is your algorithm, and that's all that is there to it as far as evaluating a postfix expression is concerned, right? So I hope you can understand and appreciate how a stack is helping the computer to evaluate an expression that you give typically for it to solve, right? That infix expression will get converted to a postfix one, and the postfix will be evaluated by the computer. The infix to postfix will be done using stack. Postfix evaluation will also be done using stacks, right? Remember this algorithm. Do not forget this algorithm. This also comes, right? And you just need to write it in your own language. As long as you remember these 2 steps, you can write it in your own language, right? So that's all that is there to this. Next, we did what we wanted to cover as far as the theory is concerned. Now we will try to solve some problems. What is the time complexity of an infix to postfix conversion? What happens in infix to postfix? Remember what happens. Suppose we have A plus B star C, right? What do? Infix to postfix means that we will take these, we will go from one element here, we will put this is an operand, right? We will put operand here, and we will take a stack, and this one will go here into the stack, right? And then we will take this operand here, right? So B, and so on, we will go on. So every element we are scanning and taking some action. Every element we are scanning and taking some action. Either we are putting it in the output or we are taking it to the stack, right? So with every element, there is something that is happening. So if that is the case, then every element actually constitutes of the time complexity of order of n. Whatever is the total number of elements, we are actually going to touch each and every element. That means our time complexity will be order of n. So the concept of brackets, the concept of operator, the concept of operands, all of these we will touch at least one time. All of this will be touched at least one time. Hence, if we total it up, then the more the number of n's, the more will be the time complexity. So this definitely will be as a function of big O of n, right? Because as many as elements or operators and operands you have, your n increases, your time will increase, because all of those elements will have to be touched. Every time you touch it, my time will increase. So if my expression is large, my time will increase linearly, hence my time complexity will be order of n. Right? So that's the answer to this. What is essential for converting an infix expression to postfix? We know that. We need a stack, of course. To convert infix to postfix, definitely we need a stack, right? We have done it using stack. This is how we had done it, right? We had taken the operands, put it on the output. We had taken the operator, put it in the stack. Then we applied some rules. So we need that. What we also need is that we applied some rules, right? You remember that if the operator is actually less than the next topmost operator that is there in the stack, then we will have to pop out those operators. So we need to know this one also. We need to know the precedence and associativity rules in order to convert it into a postfix expression. And of course, we need to know the operands also, because those operands are going directly to the output, right? So we need to know that the operands has to go directly to the output. The operators have to be applied to the with the precedence rules to the stack operators, and the stack is definitely required. So these are the three things that you definitely require if you want to convert an infix to the postfix: the rules and the instrument. The instrument is your stack. The rules are the operator precedence rules, and the rules are the operands going directly to the output. So that's what you definitely need, right? So moving on to the next question, reverse Polish notation. We have discussed that RPN is actually AB plus. Given A plus B, convert it into AB plus. This is called RPN or postfix. And we discussed that PN, which is Polish notation, is plus AB when you are given this A plus B, which is prefix. So this is a prefix notation, right? So that's on the RPN part of it. Write a program to convert infix expression to its equivalent postfix using stack. Write a program to convert infix to postfix using stack. This is your program, right? Write this algorithm, you are done with that question, right? So that's something that we have discussed. So this is also done. Next, we will move on to the next one, which is convert the given infix to postfix. Let's attempt it. Let's attempt this conversion. I think that will be a better revision for all of you, right? So if I take a stack and I will take this expression infix to postfix, don't forget what are the rules. So the rules are that I will take the element, if it is an operand, I will take it directly at the output. If it is an operator, I will push it to the stack. If it is an operand, so this is done, this is done, this is done. B, I am taking it directly to the output. Star, I will push it, but I will have to check if it is greater than the next item, right? If it is greater than the next item, I will push it. So star goes here. Next is C. So I get C. So next is on the C part, right? When I get a C part on this particular topic, what I will do is I'm going to check for a number. In fact, C, I have taken it to the output, right? And now I'm going to take, right, this minus. Okay, star was done. We had taken it. C was done. Minus. Now minus, if we have to do, can I put minus here? I can't put minus here, right? So I can't put minus here is what I know, right? Why? Because minus is less than star. I cannot put minus unless I pop out this star. Nothing will happen, so I will pop out this star. Now can I put minus here? No, because if I put minus here, still there is plus. Plus it has the same precedence. I need greater, so I will pop out this also. So I will pop out this also, right? So this minus is also done. Next I have D, right? So I need D to be included here, right? So what is D? Direct output. Then I have exponent. I told you, right, originally that dollar and exponent are taken interchangeably. So you have given, they have given a dollar. So we will treat this as an exponent. And exponent, since the stack is empty, I can definitely put dollar here, right? And even if it was not, dollar has the highest precedence, right? So we will put dollar there. Now we have F, which comes here directly, right? And then we have F is done, then we have slash. So slash I have to put here. Can I put slash here? No, dollar has higher precedence than slash. So dollar has to be popped. If dollar is popped, it will come here, right? If dollar is popped, it will come here. And therefore, I can now put my slash here. And then I can definitely attack my H. H is an operand, will come here. Slash, therefore, see the stack, the word is, the expression is over. When the expression is over, what did we say? Whatever is in the stack, just pop it out. So whatever is in the stack, we will just pop it out, right? But there is a minus missing somewhere, which we have not accounted for. This minus, somehow I have missed addressing this. So let us go back and address this and do it correctly this time, right? So just bear with me. Somehow this minus got missed. So what we will do is do it again. So A comes to the output, plus goes to the stack. B comes to the output. Let me put the tick marks, otherwise I'll miss it again. So A, B plus is done. Star, I can put star here. Yes, I can put star here because it is higher precedence. Then C comes here, that I can do. Minus, if I want to put it here, minus cannot go because star is greater than minus. Star has to be popped. So I will pop star here, and I can put minus here. No, I can't put minus here. Why? Because plus is there, it has to be greater. I have to pop plus. So pop, I will pop plus, and this minus will now come here. I don't think I put this minus in the last time we did it, and that's what created this problem. And now we have D. So we have D here. Then we have dollar. Dollar can go easily on top of this, right? So dollar goes on top of this. And then we have F, which is coming here. And then we have slash, which is going to come here, but slash cannot come here because dollar is here. So we will have to pop dollar out. So dollar will come out. And because we have popped dollar out, can slash reside here? Yes, it can reside here because slash is greater than minus, right? So slash can reside here. So therefore, we will say that this is valid, and we have done with slash. Then we will do the H. H will go into my output. And then what we are left with in the stack, because my string is over, expression is over, I'll have to take all of the stack and just print it and pop it and print it. So I will print this, right? So I will pop this, and I get what is basically my answer, right? So this will be the answer to this particular problem. Be careful when you are doing it. I made a mistake just now by missing something. Some amount of concentration lapse will lead to making a mistake. When you are doing this problem, right, be very, have your concentration at the highest level. This says infix to postfix expression using stack, right, with a detailed expression. So again, we will do the same thing. Let us practice this out. It says A minus B, C, etc., etc. There is brackets here. So be careful. This question is important. There is a bracket, and we will have to solve the brackets in a manner that we have already learned. So let us put A here because A is an operand, right? Minus is an operator. It will go here, right? Next, we have a bracket. Bracket will be blindly pushed into the stack without checking anything, right? So bracket will be blindly pushed into the stack. Next, we have B. B will come here. Next, we have bracket. right? Next we have division. Now division, as I said, bracket is a lowest priority, so division can definitely sit on top of bracket, right? Because division is highest priority. Anyways, bracket is of lowest priority. So now we can go to C and print it here. Then we go to plus. I cannot put plus here. Why? Because there is a division which is of higher precedence. I'll have to pop this out, right? If I pop this out, then I can put a plus here, right? I can put a plus here because this plus is anyway greater than the bracket, right? So if I have popped this bracket, division sign, then I will need to show this division sign in my output, right? So that is done with the plus. Then we have another bracket, right? So we have another bracket means we will put that bracket here. Bracket means blind push. So we will push the bracket blindly into the stack. Then we have a D, right? This D, what we will do, we will print. Then we have a percent. Percent, can I put it here? Yes, I can put percent here because percent has higher precedence than a bracket. Bracket has the lowest precedence, as I said. So percent is there. Then we have E. So I will print E. Then we have star. Can I put a star here? Can I put a star here? I can't, because star and modulo have the same precedence. It has to be greater. So I'll have to pop this out. So I'll have to pop this out. That means I'll have to write percentage here, and then I can put a star here, right? So this modulo, this star I have done. Then I am doing an F. Then I have a bracket. Now when I encounter an end bracket, the rule says you have to go till the first bracket that you will encounter, and you'll have to pop all the items. So I'll have to pop this star, right? I'll have to pop this star, and I'll have to pop this bracket and discard it, right? So I'll have to pop the right bracket and discard it, which is fine. So my stack now looks like this, right? So brackets work, the right brackets work is done. So this is also done. Now I see a slash. This slash I will push here because that is my top of the stack right now. Now I see a G. So I will push this here, G. Now I see a bracket. Now the bracket, what I will do is the bracket, I will have to push this bracket till I'll have to pop everything till I get this bracket. So for this bracket, this right bracket, I'll have to go till this starting bracket, right? So I will have to pop this out, which is this. I'll have to pop plus out, which is this, and then I'll have to pop this out, which is going to be discarded. Brackets are discarded, and then I'm done with the right bracket. Now comes a star. So can I put a star here? Obviously I can put a star here, right? Because I have minus at the end, right? And then I have H. So I will put H. My string is over. I will pop these in order and write them in order, right? So that is what you get as the expression for solving this. If during this process you are slightly way off in your concentration, then it is this will be definitely a wrong answer that you will get, right? I have done it multiple times, and multiple times if I saw that my concentration was lapsing, I made a mistake, right? So please be very, very careful when it comes to stacks and pushing and popping from the stack, right? You will be because you will not have a different color entity to probably show your stack. You do not have the liberty to use rubber and pencil because that will take a lot of time, right? So you'll have to cut like this and do your problem, right? And that will actually lead to some amount of confusion. So be careful. Next problem that we have is on this. Evaluate the postfix expression using stack, right? So we have to, now this is already in postfix. Now we have to use a stack to actually evaluate it. We have learned that also. So postfix is just the reverse. We'll have to push the operands into the stack. So we'll push 2, we'll push 3, we'll push 1. As soon as we get an operator, what is the rule? The rule says pop out the last 2. So 1 comes here, 3 comes here, right? And apply the expression. Apply the operator. So this becomes 3. So this 3 will be actually pushed back into the stack, right? Next, what do we have? We have plus. So then pop out. 3 comes out, 2 comes out, and plus gets applied, right? 3 comes out, 2 comes out, plus gets applied. So you get 5. 5 will be pushed back into the stack, right? Then comes your 9 gets pushed into the stack, minus comes 5 and 9 will come out, 5 and 9 will come out, minus will be here, and this will be minus 4 will get pushed into the stack, and then because there is no further expression, pop this out as your answer, right? So I hope you understood how we arrived at this. So our next problem is going to be on this one. Let us remove this postfix equivalent of the prefix star plus AB minus CD is whatever we are trying to achieve. So what it says is, again, we'll have to probably evaluate from the prefix. We will have to evaluate the postfix. This is kind of different problem to solve. So what we will say is that we have a star. Remember, this is a prefix, right? What was a prefix, if you remember? A plus B is treated as plus AB. That's your prefix, right? So if you are actually doing this, then can you interpret this as this? Let's say, can you imagine that this prefix plus AB is actually nothing but in terms of postfix, it would have been A plus B. I'm sure you can appreciate this. Star plus AB means plus has to be applied to AB. So the infix of this would have been A plus B. And similarly, this minus CD, right? Minus CD would have been C minus D, right? So C minus D would have been the infix of this particular expression. Now, can you understand that? This particular expression is one number, and this particular expression is one number, and you have a star here, right? So I hope now you can understand where we are getting at, right? So what we are getting at is there are two numbers here and there is a star here. What is our ask? Postfix. We can just move the star this side, right? But to do that, first we'll also have to convert the infix to a postfix. How do we convert this infix to a postfix? Can I write this as star of A dot B plus? Of course I can write it. That infix A plus B in postfix will become A dot B plus. And similarly, C minus D will become C dot D minus, right? And we have still this star here. So star, now what is this? This is a number. This is one big number. This is one big number. Star here means star is applied on a prefix to these two numbers. What does that mean? That means that these two numbers will stay as it is, and these two numbers will stay at as it is, C dot D minus, and star will be applied at the end of it. So what did we do? We kept the numbers the same. We kept the numbers the same, and all we did was, these are the two numbers, right, coming up from the top. All we did was we put the star at the end of these two numbers. That makes it a postfix expression, right? So that makes it an RPN, reverse Polish notation. So what we did, just to recap, we just took the A plus AB and said that plus AB means infix mein it should look like A plus B. We took minus CD and said minus CD in infix should look C minus D. We kept star same. Then we said these are two big numbers. If these are two big numbers, can we apply postfix to this A plus B? Then it becomes A dot B plus. C minus D will become C dot D minus, right? We still have star outside. So now we have two big numbers like this. So we will have to treat this as two separate numbers. Star, if is applied onto these two separate operators, operands, will look like take the operands as is, take the operand as is, and then apply the star. And that becomes your postfix RPN, right? So that's your answer as far as this particular problem is concerned. Evaluate the postfix expression using stack. So again, we'll have to evaluate using stack. If you remember, what all we need to do is push this into the stack, push this into the stack, push this into the stack. So this is done, this is done, this is done. What we get? Plus. Plus means pop these out. So 2, 16, apply the plus. 18 goes back into the stack, right? So this is done. Now next step is around your star, right? So if you get a star, then do a star of 18 and 3, right? So what you do is 18, 3, do a star of it. And remember, every time I'm writing 18 to the right, because that's my A and this is my B. And if you remember, B operator A is the syntax. So 18 into 3, I don't have my table strong. So this should be 54. So then we have 54 coming up here, right? So this star has created this 54, and then we have 12, which is going to come here, right, on this particular element. And then we have 6, which is going to come here, right, on this particular element. And then we have slash. So slash means 12 will come here, and 6 will come here. This is something that I was doing wrong. Okay, so 6 will come here and 12 will come here, slash will come here. So this will become 2. So 2 will be, these 2 will be popped and 2 will come here, right? So that's how your stack will look like at this stage. Now what will happen is we will have a minus, and that minus, for doing that minus, we'll have to pop this out. So 2 will come here, 54 will come here, we'll have to do a minus, and this will be 52. 52 will be pushed to the stack. We have ended our expression. If we have ended, we'll have to pop 52 back as the answer, right? So that is how we will solve, or we solve this problem. Next question is around stack cannot be used in evaluate an arithmetic expression in postfix form. Of course we can use stack towards that. Implement recursion, yes, last lecture, please watch it. Allocate CPU resources, yeah, doubtful, but let us check the last option. Convert infix expression to its equivalent postfix, stack can be used for that. So of course C is my answer, right? So this is my answer. Next, I think we are almost to the end. Yes, only two more PYQs to go. Convert infix to prefix using stack. So this is again tricky, because we are now saying that we will have to convert an infix to a prefix, right? So this is an infix, but we have to convert to a prefix. We don't know how to do it. We have not seen that, right? All we have seen is infix to postfix. Infix to prefix we have not seen. How do we do it? So first we will actually do a reverse of this particular expression. So reverse the infix. So reverse the infix will look like this. There's nothing much to explain here, but reverse the bracket also. Remember to reverse the bracket also. Remember to reverse D and E. Everything should be reversed. The bracket should be reversed. That means don't start the bracket with D star E plus F. Start it from the reverse side. Start it from here. Start it from here. So basically that's how it is. So go like this, and write all elements from left to right. Read right to left, right, left to right, right? So that's what you get here. Now, if you postfix this reverse, right? Reverse the infix means now you have got this reverse. Now assume that you will have a postfix. You need to do a postfix of this. This is what? Infix, right? This is at the end of the day. This is also an infix. We have reversed it as understood, but it is also an infix. Now we have to reverse. If we have this infix, can we convert this into a postfix, right? If we can convert it into a postfix, then the postfix of the reverse will look like this, right? Let's see how much time will it take. Not much time, right? Let's do a reverse. Let's do a postfix of this particular infix, right? So what will happen? We will take G. We will take G. Star we will put here. Then we will have a bracket. We will put it here, right? So we will have a bracket. We'll put it here. Star done. Bracket done. Right. Next, let us see what else is left. We have F. So F is coming here. Then we have plus. Plus will go here. Why plus will go here? Plus anyway is greater than bracket. Bracket has the lowest precedence. Then we have E. Fine. We have star. Star will go at the top. Yes, star is greater than plus. It can go. Right. So we got E, star. Then we get D. D is also here. Now we get a bracket. When we get an end bracket, our job is to pop everything till we reach this bracket, right? Pop it. So star comes here, plus comes here. This bracket gets discarded, right? Then we have plus. Plus comes here. Then we get star, C. C comes here. Then we get star. Star comes here. Can it stay? Yes, it can stay. It can stay because plus is lesser, right? So we have plus, we have C, we have star, then we get B, right? So we get B, this B comes here, then we get plus. I cannot put plus here because there is a star, right? I'll have to pop this. Can I keep this? I'll have to pop that also. So what we have, CB star, because I popped the star, and I have to pop this also because it is at the same level as me, right? So I will have to pop this also, and then I can actually put my plus here, right? So I can actually put my plus here. Then I have my A, this A comes here, and then because this string has ended, I will have to pop these out as my this one. So I have I think this is wrong because we have 3 stars here. There should be 3 stars, so there should be a star here, right? So the postfix of the reverse is going to look like this, because I have to pop this, and this plus and star will have to be coming here. So there is a typo here that it was coming with 2 stars. We have to have 3 stars, right? So this is the postfix. Now if you reverse the postfix, right, the reversal of the postfix will look like this, right? So reversal of the postfix will look like star plus A. So just go from this side to this side. So then it should look like this, star plus A plus star B. So reverse the postfix. So reverse the postfix will bring you to a prefix, and our job was to actually do a prefix. Adjust that prefix, you will get the answer. So this is your answer that you will get as far as converting to a prefix is concerned. So step 1, when you are given such a problem of infix, right, just reverse it to another infix. So this is one more infix, right, reversed infix. Then step 2, you do a postfix conversion of this infix which you are aware of. Step 3, again reverse this postfix. As soon as you reverse this postfix, this will become a prefix, and that's your answer, right? So that's the way how you will probably solve this problem. Now the last sum that we will do is this: convert infix to postfix. Should be easy enough for all of us. Let us attempt it. We have a bracket, so we will push it into the stack. We have A, we will bring it here. We have plus, we will bring it here. We have B, we will bring it here. Let us mark what we are taking. We have a bracket. When we encounter a bracket, then we will have to pop out everything before the first bracket, and then also pop this out and discard it. Then we have a star, we will push it into the stack. We have a C, we will bring it here. We have a minus, we will bring it here. Can minus go here? Can't, right? So we can't put a minus here because we have a star. So we will pop the star out. So star, it will pop out, and when it pops out, minus can come here. We have a bracket, we will start a bracket. We have a D, we will write the D. We have a we have a E, minus. Can I write my minus here? Of course I can. I'll write my minus here. Then I have an E, I will print the E. I have a bracket. Now this bracket will take off all this, right? So minus will come here. Bracket gets discarded. So we have an E is done, bracket is done. Another bracket starts from here, right? Then we have an F, then we have a plus. F is done, plus we will put here. Then we have a G we will put here, and then we have this bracket will take off this plus and this bracket, right? So we have a plus, bracket is discarded. We have ended this string, therefore this minus will also be popped out, right? And this will be your solution to the infix to postfix conversion. So this 1 minute that I just spoke and wrote and racked my brain to do whatever has to be in utmost concentration. Otherwise, this will be going for a toss. I'm repeatedly saying this, right? With that, I think we have done a lot of problems. We have done a lot of PYQs, and as you can see, a lot of PYQs are coming from these infix postfix problems. Algorithm is also coming. We have discussed the algorithm. I hope it is clear to all of you in terms of what you can expect as questions. I hope it is clear why we are choosing postfix, so that we can solve the problem in a much better manner, and that I hope takes you to the point of belief that stacks and applications of stacks are actually the core to actually solving a lot of things that a compiler would actually want from you, a lot of things that conventional codes wants from you. So with that, we will end this lecture and we will move into the next topic, which is Q, from our next lecture onwards. But I hope this has been useful to you. Till the time we meet for the next lecture, have a nice day ahead.